Welcome to Chapter 4, Segment 2. This is Miss Lewison. We are continuing on with climate. Climate is a generalization of the temperature and precipitation patterns in a region. Convection currents are the air cells that occur along the Earth's surface and create our global wind patterns. Hadley cells occur along the equator. The Hadley cells occur as warm, humid tropical air rises at the equator. As the air rises, it goes through adiabatic cooling, which results in heavy precipitation. The air continues to rise and ultimately becomes cold and dry. The air pushes either north or south from the equator as additional air rises along the equator. Eventually, the cold, dry air begins to sink and increases in temperature due to adiabatic heating. The air that reaches the Earth's surface is ultimately hot and dry, which results in the location of many of the Earth's deserts. So, while I just said that the warm air in the Hadley cells rises at the equator, that's not exactly true. Due to the Earth's tilt, the most intense light does not occur along the equator, but actually along the ITCZ, the Intertropical Convergence Zone. You should be able to explain what the ITCZ is. So the Hadley cells occur along the ITCZ. At the poles we have polar cells, and in between the Hadley and the polar cells are the Ferrel cells. This diagram includes the Hadley cells and the polar cells, but where you see the green arrows along the Earth's surface are the Ferrel cells. Looking at the Hadley cells, it looks as though the air moves from 30 degrees north straight down towards the equator, and in theory it should. But the Earth is rotating on its axis, which causes the Coriolis effect. The Coriolis effect is a deflection of movement, 45 degrees to the right in the northern hemisphere and 45 degrees to the left in the southern hemisphere. The deflection occurs to winds and water currents as well. The resulting winds are called trade winds from the Hadley cells, the westerlies formed by the Ferrel cells, and the polar easterlies formed by the polar cells. This is another diagram showing the Coriolis effect, or the deflection caused by the Earth's rotation. The deflection is to the right in the northern hemisphere and to the left in the southern hemisphere. The trade winds, westerlies, and polar easterlies end up blowing across the oceans, which causes the water to move. The water is also affected by the Coriolis effect, so the resulting currents flow parallel to the equator. As the currents travel across the ocean, they eventually run into the land masses and turn to either the north or to the south. Those waters then join a current that travels back across the ocean that's formed from the Ferrel cells. This results in large circular currents in the ocean called gyres. Gyres are important to our climate because they redistribute heat around the Earth, as demonstrated by the red arrows, which are warm currents, and the blue arrows, which are colder currents. There are 5 main gyres, one in the northern Pacific Ocean, one in the southern Pacific Ocean, one in the northern Atlantic, one in the southern Atlantic, and one in the Indian Ocean. Moving on, then there's the ocean conveyor belt. This is a large, slow-moving current that connects all the oceans. The ocean conveyor belt is driven by changes in water density, not winds. The red arrows are surface currents, and the blue arrows are deep water currents. Along the ocean bottom, the ocean conveyor belt is important because it mixes all the oceans. Then, there's thermohaline circulation. Thermo is temperature and haline is salt. This is the vertical movement of water due to changes in density. Colder water or saltier water is denser and will sink, while warmer water or less salty water will rise. Thermohaline circulation is important because it moves nutrients from deep water to surface waters, as well as redistributing heat. Let's move on to the Earth's seasons. Seasons occur to the Earth's tilt on its axis. As the Earth revolves around the sun, the tilt of the axis causes changes in our temperature. When the northern hemisphere is tilted towards the sun, it is summer, and when the northern hemisphere is tilted away from the sun, it is winter. The tilt is also why the northern and southern hemisphere have opposite seasons from one another. This diagram will hopefully help you visualize the pattern of the Earth's seasons. When the Earth is tilted towards or away from the sun, when the Earth is not tilted away towards or away from the sun, that is either fall or spring. If you are unclear about any of the concepts, please let me know so I can explain them further in class. El Niño Southern Oscillation is the most important climatic event for you to understand by far. El Niño is an event that occurs in the Pacific Ocean every 3 to 7 years. It starts around December 25th, which is why it is called El Niño. It usually lasts about 1 to 3 years. Under normal conditions, the trade winds in the Pacific Ocean blow warm equatorial water towards Asia. In an El Niño event, the trade winds weaken, allowing the pooled warm equatorial water in the western side of the Pacific to flow back towards the eastern Pacific Ocean or the Americas. The consequences that occur affect numerous areas. So, the consequences include storms and flooding in the Americas, droughts in Asia and Africa, and a significant loss in the eastern Pacific fisheries.
A natural force of nature unlike any other, El Niño is capable of unleashing a fury of climate changes and natural disasters that span from Alaska all the way to South America and beyond. What causes El Niño, and how are we affected by it? El Niño is not a storm, but rather a weather phenomenon in the Pacific Ocean. During an El Niño, the surface water temperature warms up, leading to complex weather patterns. South American fishermen in the 19th century, describing warmer waters during Christmas time, coined the name El Niño, Spanish for the Blessed Child. Nowadays, when sea surface temperatures in the equatorial Pacific Ocean rise 0.5 degrees Celsius over their historic average for 3 consecutive months, and once atmospheric conditions and rainfall patterns shift accordingly, scientists officially declare an El Niño. An El Niño event takes place about every 2 to 7 years. Normal east to west trade winds over the Pacific weaken, and warm water that normally travels westward is now moving toward the east. Moisture then rises into the air, and the effects of El Niño are felt throughout the Americas. In the ocean, warm water pushes colder water downward, blocking the important upwelling of nutrient-rich waters from the bottom. This causes some marine life to migrate to colder waters. Animals that normally feed on this sea life suffer, and fisheries throughout Central and South America suffer too. But El Niño's most noticeable repercussions are felt on land. In the western United States and Central and South America, the warm air and moisture lead to increased storms, rainfall, floods, loss of life and property, and the increase of some vector-borne diseases like malaria, even in places where they don't normally occur. In Southeast Asia and Australia, the opposite takes place. These areas suffer from drought, wildfires, and colder ocean waters. In 1997 and 98, the world experienced the biggest El Niño in recorded history. Some estimates blame that El Niño for 2,100 deaths and $33 billion in damages. Mongolia saw temperatures reach 108 degrees Fahrenheit. There was record flooding in Peru. And the U.S. saw storms in the Gulf Coast, flash flooding from California to Mississippi, and tornadoes in Florida. Scientists are now better able to predict if and when an El Niño event will take place. This helps communities better prepare for the changes in weather patterns and better adapt to its repercussions.
On the opposite side of that, sorry, my mic's up, there is La Nina. During a La Nina year, trade winds are stronger than normal, and it's referred to as an La Nina event. The stronger trade winds push more warm equatorial waters towards Asia. The results is severe droughts and possible increased fires in the Americas, and heavier than usual rains in Africa and Asia that can result in severe flooding. El Niño and La Nina also affect us in Florida. An El Nino event will usually decrease the number of hurricanes in the Atlantic, while a La Nina event will usually increase the number of hurricanes. This ends segment 2. If you have any questions, please let me know so I can go over the information in class. Have a nice day.